Howdy, y'all. So today we are going to learn about faking gravity in space. We have a little shot from the movie Elysium, and you'll see that it's a circular space station, and that's pretty common in some space movies, not in all of them, like Star Wars. Um, they make gravity, but not using a circle. So how do they do that? I don't know. But in real life, this circle has a real physics sense to it. So let's take a look at what this is all about. So here we have the International Space Station. And
Hello, I'm Sunny Williams. I'm up here on the International Space
what?
Station.
She's talking. So this is
So
Sunny
this is Node
Williams,
2. This is a really
and she's
cool
on the International Space
module.
Station. If this
Of
will go
course,
full
most of
screen, we'll
these
see her.
modules you
There she
see have
is.
four
And she's
sides,
going to tell you all
and
about
they're
like how
put
she
together. That
lives
way we can sort of
and
work on a flat
where she sleeps and how to
plane,
brush her teeth. In
either
fact,
a wall,
let's
a
go watch her brush her
floor,
teeth a
another
little bit because
wall,
water
or
in
the
space is
ceiling.
really
Like,
actually pretty cool. Oh, there she goes. She's
you
slipping
see it?
around. So here's
I'll
some
have
water
some
out in
water come out.
space. And you can see the
Water is
drop
pretty
just kind of
neat up in
chilling out there,
space.
right?
It'll stick to your
And
toothbrush, and
here
it
we
will make
go. Water all over the place, right? Just forms a nice little sphere.
a big bubble.
And anyways, this is
And that's just by surface tension.
pretty cool.
And then you can
Drink it. Okay. Bye,
drink it.
Sunny.
So a
So,
lot of people ask about
anyways,
what do you
the
do
International Space Station doesn't have
with the
gravity.
toothpaste
So
after you brush your teeth.
she's out there chilling. And
Two
please stop.
options.
She's out there chilling out in space with no gravity. And so, if you're out in microgravity for too long, it can cause things like damage to your bones, your spine, to your arteries. And so this is something we really do have to deal with. And so one of the ways that we deal with it is by making kind of this circular rotational habitat. And so here's one you see here. There's an infographic from space.com, and this was put up by NASA a long time ago. And it just basically shows a huge space colony here. And for some reason, it's not letting me roll down the page. There we go. This one is actually from 1928. And so this guy, Herman Potoknik, Nordung, in 1928 wrote a book about space travel. And you can see the little guys, they're going up an elevator to the middle and they're walking around here and they kind of got this little escalator thing and their life happens on the inside of this rim. This little donut shape of this bicycle wheel thing is called the torus. A couple more here. O'Neill Cylinder Island 3. This thing is 20 miles long, right? That's a big one. And there you have it, just this giant inside of this thing. And this one's called the Stanford Torus. This is the one we're going to actually kind of deal with in our quiz today. It was made by some Stanford University students. It's supposed to house 10,000 people, and it's 1.1 miles in diameter, and it spins 1 RPM. So it's big enough actually so that you don't get too sick because you can't feel it too much. It's spinning 1 RPM, 1 revolution every minute, and it's almost a mile in diameter. So it's pretty big. Not tremendously big though. This is 10,000 people. It's a lot of people, right? There's 10,000 people for this Bernal Sphere Island 1, 2. So, anyways, that's the idea that we have today, these spinning space habitats. And so this guy named Nick Lucid, he's got a little cute little 5-minute video. He's a mad scientist, and he's going to talk about things like what would happen if you let a balloon go? Where would it go? It's a good question. Where would the balloon go if you let it go? What would happen to it? Um, and then what would happen if you ran fast? What if you ran fast downhill? I don't know, with the spin, or what if you ran fast against the spin? What would happen? You can actually on this next one, it's another guy about I don't know 6 or 7 minute video, and he talks about whether or not we could do it. But he also talks about how much it would cost to do. So that's pretty cool if you want to figure out how much it would cost to build this giant space station. I think he actually uses the Elysium space station as his example of how you would build that using like Elon Musk's BFR, the Big Falcon rocket, to carry all this stuff out into space. How much would it cost? So that's an interesting one too. Okay, skipping ahead to how this actually works. So this is the Stanford Torus, and we're going to figure out how much I would weigh if I was on the Stanford Torus. And so, how do they construct this? What was the physics behind it that tells you how you get weight? And so, first of all, what we want to do is we want to, think about, okay, what is Mr. Morrison's weight on Earth? And so, my mass is about 70 kilograms, and weight is Fg, and Fg is mass times gravity. And so, you guys should know how to do this by now. 70 kilograms times 9.8 newtons per kilogram gives me 686 newtons. So, my weight on Earth is 686 newtons. So let's see if we construct the Stanford torus to be similar to that. So you should really follow along with this so that when it gets time for the test and I ask you this question, which will be a test question, you'll be able to figure out how much a person would weigh in a spinning space station. So here we go. So here are our knowns. My mass is 70 kilograms. The diameter of the station is 18 kilometers, but you got to remember we got to change that to, sorry, it's 1.8 kilometers. That's a point. You can't see the decimal there very easy. At least I can't see it. That's we're going to change it to meters. The radius is 900 meters, so the diameter is 1800 meters. And then velocity. I told you before it spins 1 RPM, which 1 RPM is 1 revolution per minute. So if it's 1 revolution per minute, it's also 1 revolution every 60 seconds. We want to change this to meters per second. So the way you get the meters is you do a circumference, and circumference is pi times diameter. So here we go. The velocity is going to be 1 circumference, which is pi times the diameter, divided by the time. And so how fast is it spinning? It's spinning about 94.2 meters per second, which means it's about 1 football field every second. So I don't know. I guess you probably would feel that, but you might get used to it because it's so big. I guess if you had a smaller space station, it's really going to spin around like a carnival ride. But this one's pretty big, so you probably would feel it, and maybe when you moved around, you would feel it, but you hopefully would get used to it. Okay, so how do I figure my weight? Well, the way you figure out your weight is using the centripetal force equation, which is at the top of this right now. Fc equals mv squared over r. And so centripetal force is the way we actually get weight by spinning this thing. And so centripetal force is mass times velocity squared divided by the radius. And so it's pretty simple. In order to get my fake weight, I'm going to take my mass is 70 kilograms times the velocity, which we had to figure out before was 94.2. I'm going to square that and divide it by 900. And what do you get? Drum roll. You get 690 newtons, which is pretty darn close to what we had on Earth of 686 newtons. And so that's why they designed this size and this shape so they could fake gravity out in space. Okay, so now it's your turn. You're going to go to the look at the Rockland torus, which is Rockland's students are going to design a spaceship that spins in space, and they're going to do quiz 4.2 on Sparky Science. So have at it, have some fun, and I will talk to you later.